Hello everyone and welcome again to Arctic Game Talk. I'm Johan Linde and this is my colleague
Emma Prieto.
And Emma, you work as community manager?
Yes, I work as a community manager for Goodbye Kansas Labs. And I work mostly with the recruitment of new students now for all the game educations in the Arctic Game Lab. From this fall we actually have a lot of new educations. So
it's a lot of work.
Yeah, it's a lot of work, and if you want to know more about those, you can visit the webpage. We're gonna post a link.
Yeah, but you're an alumni and you've studied some game educations before, and now you're in the games industry. How is it to start working in this?
I think it's amazing. I love it. It wasn't the way I thought to begin with. Since the coronavirus came along, I had to change the plans a little bit, but I like it. It's exciting. It opens new doors, actually. So
fantastic. All right, so let's head into some Arctic Game Lab news then. We will have a meeting in May about the first project that we run in Arctic Game Lab called Innovation Game. That project actually ended in August last year, and we will have a meeting to present the results of that project. And we will have an invite for everyone that's interested quite soon. We're working to find a date that will work for everyone in the panel, but we will have a date soon, and then you'll know. And you're of course really welcome to join in and listen what we learned from that project. Cool. We're also going to have some equality talks.
Yeah, we're going to have some equality talks, and we're going to start the next Wednesday, actually. We're going to have one about why it's important with equality in games. That's the first one. And then we're going to have inclusive game design, equality in company projects, and communities and organizations for female game devs. And that's a project that we have
together with L2.
Exactly.
Yeah, Luleå Technical University.
Yeah.
So that's going to be focused mainly toward the students, but you as Arctic Game Lab community, of course, welcome to join in and be a part of it. Yeah. It's good.
Yeah, we're going to post more information about that too.
Yeah, and you'll if you just follow us on our Discord, you'll see it. All right. We also have Emil Sandberg with us today.
Good morning.
Good morning. So you're joining in from Boden?
Yeah, from the northern part. We started, actually when Arctic Game Lab started 3 years ago, it was a great idea to collab with all the municipalities, and we wanted to create an ecosystem in Boden. So now for the 3 years we've been running, we have a new building for 5,400 square meters just designed for the game industry. Together we have this fall we will be up to 120 students, 9 companies, 2 from Seattle, and to bring all that to one environment in one building. I think that's great to collab with students, internship, business, and big studios to be able to eat lunch or just meet up quick.
Yeah. And what do you do in Boden? What's your role?
I'm a project leader for Boden's part in Arctic Game Lab and business developer for the game industry. So my role is to see that all of the students has their all-inclusive package when they come here to apply for the educations, that the companies has the great sources and infrastructure to build their studio and to find their talents to bring up their businesses. So I would like to say everything that's included game industry here.
Yeah, and I mean Boden has put a massive amount of energy into building the games industry. How does it reflect in Boden? Does it feel? Does the game industry is it a feel of the games industry in Boden?
It's from the beginning it was kind of hard, but now I would like to say most of the people in Boden is really proud of the game industry here, because now they understand what it is and what they do. It brings job, it brings talents from other part of Sweden or the world to actually move here and live here in Boden. I mean, if we go back like 10 years from when I went to school, most of my friends and school friends was just, yeah, they wanted to move out, and now it's been going the other way.
Yeah.
That's fantastic to see.
Yeah, it's really, really impressive. I mean, when I grew up, we had a different image of Boden. So Boden to be a games industry city is fantastic. You're doing a really impressive job there, so keep it up. And if anyone is interested in knowing more about Boden or get in touch with someone in Boden, you have an email, emil@articgamelab.com. So please reach out to Emil and he'll help you with whatever it might be. Super. All right.
Yes.
We've been covering quite a lot about digital conferences and so on, and that's gonna be even more. And we're looking into some way for us as Arctic Game Lab to help the whole community and the companies here to participate in those in a good way. So that's probably something we're gonna see soon as well. It's gonna come more information about that, but it's a work in progress there. Good. And we also have Michael Stenmark with us.
Exactly. Michael, are you with us?
Yes, I'm muted my microphone. Right.
Perfect.
Yes, I am with you.
Yeah, so you're responsible for our digital open box. So what exactly is it you do? What is an open box?
The open box used to be a physical meeting room where students and I would say game enthusiasts and professionals meet and create games or anything creative that will sort of suit into the game industry sphere. It could be comics, film, anything like that, but mostly focused on games. So it's like a game jam which is extended, that goes on every week or each second week, depending on how we tend to meet. Now, in these Corona times, we are doing it in a digital way instead. So it is a different situation where we have a Zoom room, and I could actually screen share if you like. Can I do that? Let's see. And if I share this screen. So the open box looks like this. We have a main meeting room in Zoom, meaning that people can log in with their cameras and talk. But if we're 20, it's hard to do any group work. So we have breakout rooms underneath, so you can have a smaller group in a breakout room.
Is it a different topic in each breakout room, or?
Yeah, probably. It could be a project. Someone wants to do a mobile phone game. Someone wants to do a PC game. Someone wants to do a board game or a classical role-playing game. So that could be the topic for the different rooms. Yes. So that's how it looks. And we're in the beginning, I would say. And I'll stop share there. We're in the beginning. We don't know exactly how this will work, but it works out. We have been testing 2 times now, and we have started 2 smaller game projects, and it works.
Cool. And when's the next meeting's gonna be?
Tuesdays at 6 o'clock, and after work. And it's going to be 2 weeks from now, not this Tuesday that comes up, but the next one. And then we'll see how often, if it will be twice a week or each, not once a week or bi-weekly, not twice a week. So.
All right. Thank you. You also teach? You wanna?
Yes, I teach. Not as a teacher, because I'm not educated as a teacher, but I teach based on my professional years. I've been working with games, comics, books and films for 35 years. So I teach at the Comic School of Skellefteå, Medlefors. That's a Folk University. It's 2 years of comic school, but also the reason why we have a comic school is because whatever you do within the field of comics, you can do that and connect it to game industry. You need character design, storyboarding, you need storytelling, and you need all these different things that goes into graphic design when it comes to games. So I would say a comic artist has always jobbed within the game industry. So that's why we have a comic school in Skellefteå. And it works pretty well. It's very high standard. We have teachers coming in from all of Sweden, Scandinavia, and in the future, the rest of the world also. Yeah.
Nice.
Super.
Yeah, nu ska vi se att jag var bort mig.
So,
Right, if you want to know more about our news, you can email news@arcticgamelab.com or you could visit our Discord channel.
super. And now over to some more local news.
Yeah, we have some news from about new educations from Changemaker. It's Agile project leader, front-end developer, and the Future Games game engines. And they're going to be during 12 weeks, and the education will be spread in Stockholm, Boden, and Skellefteå.
They will start this autumn as well? Or
Yes,
Yeah.
And it's not possible to apply yet, but more info will come.
That's great. Even more educations to find students for. Fantastic. That's going to be good.
It's going to be good. And then I'll just also say this weekend actually I started a new Facebook group for alumni in Skellefteå. And we already reached over 300 members in the group. So if you're an alumni, please check that out. I'll send the link there too.
That's great. It's been so hard for us to actually find those alumnus. There's a huge lot of alumnus that has passed through the game educations here, and it's been a struggle to reach them.
Yeah.
So it might be a really good lead to be able to reach out to those.
Yeah, it's a very active group, so if you go in, you'll
Fantastic.
notice.
All right, then we have some global news as well. As many of you probably have heard, Gamescom just cancelled this week. We usually go to Gamescom each year, and it's a fantastic event, but it's not going to happen this year. As far as we've heard, it's going to be some sort of digital event that will replace Gamescom this year, but it will of course not be the real experience. And it's sad, but it's not that unexpected. We also have some more event updates. We have the White Knight Hub that was actually starting today. White Knights is a big game event in Russia that will be later this year, but they are already launching a digital platform, and they will host that platform until the 30th of April, and it's over 3,500 registered already. It's free to register, so please check it out. It could be a good way to start networking internationally. I will of course have a good look at it just to see how it works and what we can learn from it. We're also going to have the European Games BizDev Gathering. It's going to be in May 13th to 14th. We're looking into that, how we can be a part of that as well. Nordic Game 2020 is planned for 27th to 29th of May. That's also cancelled. It's going to be just a digital event, and it's for those that bought tickets. It's also going to be a physical event in November. But they will host a premium event, digital event, in the late May. And we will, of course, be a part of that as well. And then we know that Pocket Gamer Connects has made a digital version that's going to run in June, 8 to 12. And we heard from Oscar Clark last week, who was participating in the first event that they run. It's really working well. It's of course not the real thing, but it's as close as you can get, and it's a lot of good business opportunities. So that's also coming up, and as I mentioned before, we are trying to find ways where we can help the companies and the communities to be a part of that and do it as good as possible. All right, that's it with the news from Arctic Game Lab. We're gonna have the guest for the week now. So joining us from Umeå, we have Peter Sundqvist, your technical director at Turborilla.
Thank you. Yeah.
Super fun to have you here as a guest in the Arctic Game Talk. How are you?
I'm very well, thank you very much.
Fantastic. So you're going to talk a bit about optimizations in Unity and mobile.
That's right. So I'm gonna share my screen.
Perfect.
Here. So there it comes. Yeah, thank you, Johan, and welcome to the short optimization workshop. So as you said, my name's Peter, and what I do at Turborilla is mostly solve technical difficulties in our games. And this workshop was actually something that we had internally a few months ago. And I felt the need to have one because we're in the process of soft launching our next game. So we're getting to the stage where optimization is important. And now that we have actually soft launched the new game in Canada and the Philippines, and we're gathering some data on that. And I should say, when I talk about optimization, I mainly mean increasing the frame rate of the game and increasing it on devices that are not as fast as the top ones. But also, I'm going to talk a little bit about reducing battery power usage and reducing the size of the app. We mainly make mobile games. For the last years, we've only released mobile games, and the app size is limited by Google's and Apple's services. So you have to go under the limit to release the app, which enforces you to be a bit conservative with size. And I should say that this workshop is heavily focused on mobile games and Unity, but I think that most of it will be interesting even if you're not working with Unity and even if you're working on console games or working on PC games, because the general concepts are the same everywhere. So to start off, I would like to show you a 15-second video of our upcoming game. So I'll just start it here. And this is a short advertisement video we made for the soft launch to try to get some new players into the game. And it had to be only 15 seconds because that's the amount of time you have to catch the user's attention on Facebook. Yeah, and this just shows you, gives you an idea of the game we're making and kind of how the graphics looks like and so on. I can say that the game looks much better now than this video. It's a bit old and we have improved a lot of stuff since then. And this workshop is gonna be super technical. So don't worry if you don't understand everything, if you're an artist or if you're a student or if you're not a technical person. I will come to some interesting things for artists and other people than technical people too. And we actually forced our artists to join the workshop we had a few months ago because some concepts are interesting for them as well. And if you should remember something from this talk, it's this slide, and it shows the profiler in Unity. So before optimizing anything, you should get into the profiler, and you should connect your phone or connect to whatever device you want to run the game on to the profiler in Unity to see where your program spends time. And when you connect it to a phone and run the profiler, you get these graphs over here, and you get these boxes that show the number of milliseconds of each function in the game. And what we usually want to do is to reduce the number of allocations we do every frame. If you allocate a lot of memory, it will have to be cleaned up sometime, and that will take some time from the processing power and make your game sluggish. So these red boxes show allocations, and you can click on them and you can find out why are we allocating memory, can we do something about it? And from this graph, this is from our newest game, we can see that the player physics update function is what's taking most of the time, and that's our in-house physics engine. So it's tempting to start optimizing the physics engine to save some time and render frames at a higher rate. And you can run a deep profile to get more detailed info. It doesn't work that great on mobile devices. So you can run the profiler also on your PC in Unity, and you will get a somewhat similar result to the mobile device when you deep profile. But I recommend doing most stuff on the phone because there can be a big difference. And a good tip when you start optimizing is to just delete the entire section you want to optimize. How many milliseconds can we actually save if we just delete the entire physics engine? And we may see that, okay, this big chunk actually didn't matter that much in the end because we're stalling the CPU and we're stalling the graphics processor in some other task. So actually we're not saving that much time, or something. It's actually something else that's the big bottleneck here. So just delete the part and see what happens. Then a big question when you're optimizing games is your game CPU bound or is it GPU bound? Is the CPU processor waiting for the GPU to finish or the other way around? And there's also a tool in Unity to check this. You can open the profiler and look at the GPU usage, and then you will see two numbers there, the milliseconds on the CPU and the milliseconds on the GPU. And in this example here, I don't know if the numbers are perhaps too small for you to see, but the GPU is spending a lot more time than the CPU. So it would make sense to start optimizing on the GPU, optimizing the graphics draw calls and stuff like that. And good to know about this profiler is that it's only supported in OpenGL on Android, and you have to run a device with an NVIDIA or Intel GPU. And on iOS, it's only supported for OpenGL as well. So if you're running Metal, like I think most games are starting to do, you have to run Xcode's GPU frame debugger, which is also good to find the source of delays in the game, low frame rate. And actually, if you look at this previous screen, to the right here, you have some green boxes. That's the GPU working with graphic stuff, and the blue boxes is the CPU working with updating the logic of the game. So if we find that the GPU is the culprit for our low frame rate, then we should start optimizing the draw calls in our games. The less draw calls you do, the faster the game will run. That's the general rule of thumb when optimizing graphics processing. Less draw calls, higher frame rate. And you can open the frame debugger in Unity, and you can do that. You don't have to connect it to a phone or anything. You can do it directly on your PC or Mac. And then you can see all the draw calls on the left side here. And you can count the number of draw calls, and we want them to be as few as possible. And a great way to reduce the draw calls is to use static batching, that you combine a big number of meshes that you want to render, a big number of triangles, you combine into one static draw call that can be made. Just rendering a big bunch of stuff in one draw call. That means that these things cannot move around. They have to be static. And you can also use dynamic batching, which means that Unity will find the triangles you want to draw on screen currently and put them together into one draw call and draw them all at once. Thing with the static and dynamic batching is that you have to use the same material, same shader and same textures and so on to make it into one single draw call. And it's very useful in the frame debugger that you can go in and click on a draw call, and you can see it on screen, what actually gets drawn on screen, and you can also see why it can't be batched with the previous draw call. And the usual reason is that the previous draw call is having a different material. I want to render a blue bike, and then I want to render a red bike, and they can't be combined because they have different materials. And there's some other typical graphics tips when optimizing for frame rate, and that is to draw the opaque meshes front to back. So it's unnecessary to draw a pretty background and then just draw a character that covers the entire background. So draw the character first and then draw the background, and you can save a lot of pixels on screen. And it's the opposite, of course, when you render something transparent, you have to render it back to front. And it's good to know that Unity has two ways of sorting stuff. You can use the sorting order, or you can use render queues, and the sorting order takes precedence over the render queue. And you can, if possible, you should avoid the transparent render queue, which has number 4000, because things in the transparent render queue have to be sorted back to front, and that takes some time. In our games, in the motocross game, we know exactly in what order we want to draw stuff, so we don't have to put anything into the transparent render queue, because we want to render it exactly in the predefined order. We don't move the camera around the track in a 3D perspective. It's mainly a 2D game. And this slide was some food for thought for artists, and it's about texture compression. You can compress your textures and render faster and use less memory. You can check off the crunch compression over here if you want to reduce the app size. It's like using a PNG compression on an image instead of just saving raw data like a TGA image. To also reduce the size, you can avoid mipmaps. Mipmaps are different sizes of the same texture. So if you view an image on a distance, you can use a smaller size, and it will look better because it has already been pre-scaled down. And if you're drawing the same image closer to the viewer, you can use a bigger size. But saving all these mipmaps, these smaller sizes, take up 30% more memory. And if you're drawing a user interface, for example, you won't want to view it from a distance. It's always at the same distance from the screen. So you can avoid the mipmaps there and save some space, and also save some rendering time. Unity can automatically discard high resolution mipmaps, which can be useful if you're running the game on a low-end device that can't draw pretty big images. Then you can reduce to some lower quality and discard the mipmaps. The drawback is that Unity will still load the mipmaps and then discard them, so you get longer loading times than if you had two different images at two different resolutions. If you disable read and write on the textures, then you save half the memory. If read and write is enabled, Unity will save 1 copy extra of your texture of your image in regular memory and 1 copy in graphics memory. And since we're making games for iOS, we have often used PVRTC texture compression because it's the native format for all their iOS devices. And it has many drawbacks. I don't know why they have chosen that format. It's a very difficult format to use. Textures must be square, and it's not good for cartoony looking games, and not good for transparency because colors blend together in a weird way. But if you can use it, it's really fast to draw. It's good for backgrounds, for example, that are a bit blurry. And there's a newer texture compression for newer iPhones called ASTC that looks good, but only supported on iPhone 6 and up. If you use that compression, then lower devices will not get any compression at all. And those lower end devices might be the ones that have the biggest difficulties with frame rate. So yeah, you have to choose wisely. This talk will go a bit fast, as you notice. That's the way I like to do it, and I would like to cover some stuff before my time is up. So getting into shaders, we're using a graphical tool for programming shaders. It's called Amplify, and that means that you can put these different operations in boxes and drag lines between them and do calculations that way. Graphical programming, it's much faster to prototype shaders, and artists can go in and tweak some stuff. So it's very convenient to use. And if you want to optimize the shaders you make, the best tip is to use less number of textures. You can on a mobile phone use up to 4 textures, but if you can use only 1, that's perfect. That will save you a lot of rendering time. So put multiple textures into one atlas is a good tip. Maybe all 4 of your textures you want to use can be put into one, and you just offset the texture coordinates. And you can put data into unused channels. For example, if you only want to use 2 black and white textures, you can use the red channel and the green channel, and maybe put some other data into the blue and alpha channels. It's better than using more textures. You can also use vertex attributes instead of textures. So each point in your character mesh can have some attribute that's useful in the shader. You can also try not to use any images textures at all and calculate the result you want instead. For example, if you want a gradient going from red to blue, then that's an easy calculation to do directly in the shader. You don't need a texture for it. And when you make shaders, you can either select shader type to be Unity's default surface shader, which is quite advanced, has some lighting and stuff, or you can go and use unlit shaders, and we only use unlit shaders in our game. That means we have to calculate all the lighting ourselves, normal maps and so on. Everything is manually, but it's faster, and we usually don't need all that extra fancy stuff that Unity is providing with the surface shaders. You can also switch the precision of your shader. Usually it's 32-bit floating point, and you can put it to half, which is 16-bit. It doesn't look good on all type of graphics, but mostly in our games it's been good enough. It doesn't look good on gradients, for example. And you can also try to avoid the depth testing, turn the depth testing off, turn the depth right off if you don't need it. In our games, we don't really need it that much because we know the order we're drawing stuff, and we don't have to depth test against earlier pixels we've drawn. So a drawback with this graphical tool is that it mostly generates code in the pixel shader. And the pixel shader is usually more expensive because you draw more pixels than vertices. You draw much less triangles than pixels on your screen. And sometimes it's enough to do your graphical calculations at the vertex level, and then just interpolate the result in the pixel shader. So when we want to optimize something, we take the output from the graphical tool into code, make a copy of the code, make an optimized version where we try to move stuff from the pixel shader into the vertex shader, if possible. And there's a few things you might need to consider when you're moving stuff, and that is the data that you send from the vertex shader into the pixel shader has to be will be linearly interpolated for each piece of data that you send, which might not look that great. And also you cannot read image data, texture data in the vertex shader. And when you look at the code, the graphical tool will sometimes generate code that isn't as optimal as it should be. So you can look through it and see if you can remove some unnecessary things. For example, here in this code, we're multiplying the vertex position by the world matrix. And if we happen to know that the vertex is already in world space and the world matrix is the identity matrix, we could just remove this line. But when we get to the pixel shader, then we have to do kind of regular optimization. First of all, check the code from the graphical tool, see if the math can be simplified somehow. And after you have simplified the math, then can some calculations be approximated or pre-calculated? Maybe it will be better to pre-calculate some stuff and save it in vertex data and send it over to the pixel shader in the end, and then calculate it for every pixel that you draw on screen. And you should prefer unnecessary calculations over if statements. The if statements kind of hangs the graphics processor for a bit. So if you can do a calculation instead and get some unnecessary results, that's usually a win. And graphics processors are very good with vector 4 operations. If you structure your code in a way that it can be done as a vector 4 operation, for example, 4 multiplications, then that will be faster than swizzling multiplications with divisions or other operations. And you can here also go to half 4, 16-bit floats instead of float 4. In this example here, that's a real shader that we're using. We're using only half the precision for most things. And when you make a good shader and everything seems to be fine on your PC and it looks good, then you try it on a device and it's just black, and that happens quite a lot. And what's the reason for it? It's often a division by 0, or you have an unsupported texture compression format, so check the compression. Maybe your PVRTC texture is not square. You're using more than 4 textures. You're using some operation that's not supported on the device, like reading a texture in the vertex shader, not supported on some devices, but some others can actually do it. It's the pixel shader might set the alpha value to 0, the transparency to 0. And even if you're not using transparency at all, some graphics processors will still say that this doesn't need to be drawn at all, and it becomes all black. And the data format returned from the vertex shader, or the data format the vertex shader sends to the pixel shader, might not be 16-byte aligned. So that will not work on some hardware. So prefer to use float 2 or float 4 data types instead of single floats or float 3. And it can simply be too many instructions in the vertex or pixel shader. There are some websites that say exactly which devices can do what number of instructions. To save size on your app, you can set a high mesh compression. We actually saved like 100 megabytes or something from this because we weren't compressing any meshes in our games, and compressing them makes it take a little bit longer to load, not noticeable, but it saves a lot of space. And disable read-write if you're not gonna modify the mesh that you're rendering. Disable normals and text chords if you don't need them. And Unit has come with some new features that's interesting for developers, which we would like to use in our game. They call it the universal render pipeline, which is great for mobile because you can more in detail decide exactly what features you want to use and skip the rest of the stuff, like the surface shaders that you're not using. And to use the lightweight render pipeline, you have to only use unlit shaders, and then you have to do lighting and so on yourself. But we haven't been able to use the new render pipeline in our games yet, because there's a problem with the camera stacking, they call it. If you have to render stuff with multiple cameras, it requires some extra work and it gets tedious and complicated. And Unity is saying they will solve this in 2020, so we're looking forward to that. The thing is that we render stuff in different layers. We render first the game, 3D game, and then the UI, and then some 3D meshes on top of that in different different screen spaces, and that becomes a problem for the lightweight render pipeline. This is an interesting thing that we want to add that came in Unity 2019, I think. And that is, you can draw only half the resolution on the screen and then scale it up to full resolution. So you basically have to cut the screen in half, either cut it horizontally or vertically, and you only have to draw half the number of pixels. And this is especially convenient in our game that is scrolling in the X direction quickly, because you don't notice that much if you render only half the pixels while it's moving. And you can turn this off and on depending on what's happening in the game. So usually what's going on a phone is that the phone gets hot. When it's too hot, the processor slows down and you get a laggy frame rate. And then it's a perfect opportunity to kick in with this dynamic resolution, draw half the screen, and get back to a good frame rate. And the player won't even notice that something happened. Our UI in the game, the user interface, can actually be quite expensive to draw. It's great if you can, if the entire game has 40 draw calls, it's perfect. Few modern games on mobile will have that UI, I think, because we want this graphical goodness. 60 is still good as a measurement point. But if you're not careful when you do your 2D interfaces, you can spend like 100 draw calls there and waste a lot of time. And the thing you can do to solve that is put your textures into atlases. Unity can do that automatically. Set up the draw order right, so you're using the same atlas as much as possible before rendering the next atlas. And a good thing to know is that moving anything around in a canvas is a 2D interface in your game, will rebuild the entire canvas. All vertices will be allocated anew in memory, and that will take some time. This happens quite a lot if you have a lot of menu animations, or if you have a scroll list that you're scrolling through stuff, then you can see performance drop a lot. We have this problem all the time and have to go in and fix it. And a simple solution is to use more canvases. If only some parts of the screen are moving, and you put those parts into one canvas, and then it has to rebuild only that smaller part of the screen, not the entire interface on the screen. And another way to improve performance in 2D interfaces is to use tweens. The tweens do not rebuild the canvases like the animations do. Some stuff that's good to know about Unity. This is pretty basic, but maybe some people don't know it anyways, if you're using Unity. And that is, if a prefab is containing references to resources like textures and meshes, it will also load those resources. which can take a long time to load and use up too much memory. So you can instead put a lot of the stuff that you don't need all the time into addressable asset bundles, into the resources folder, or into the streaming assets, and load only what's necessary for your current level in the game. Don't load everything. And you should preload resources before showing them. If you load the resource and directly show it, you will get kind of a hiccup in the experience for the player. You can pre-warm the particle systems by playing them once. That will load their textures. You can avoid the coroutines. If you start coroutines every frame, they allocate memory, and that memory needs to be cleaned up at some point, and that will create a hiccup. The default mono behavior methods, like the update methods, are slow. So if you have thousands and thousands of objects and they have update methods, instead put them into an array and call your own update method instead of relying on Unity's update method. You can pre-allocate a pool of game objects instead of creating new ones. This we do all the time. Very, very efficient to save performance. So you have a big bunch of already created game objects ready to be used. Whenever you need a new unit or item in the game, you just pick it from the pool. When you don't need it anymore, you return it to the pool later. You can avoid using transform position and instead use local position, because if you update the transform position of an object in the game, it will recalculate the, or if you get the position, it will calculate the entire hierarchy's positions and rotations and scaling all the way up to the root, which becomes expensive. And game object find is slow. Instead, save references to your game objects. Get component is slow, save references to your components. You can use raycast non-alloc if you're raycasting and testing collision with some physics. Avoid allocations instead of using the traditional raycast methods of Unity. And game objects are in general expensive. The fewer you have is better. Yeah, this is just a note that comparing with null is actually more expensive than you think. If you have game objects that can be null at some point, it's faster to use this reference equals function than using the standard comparison with null. And that's because Unity will do a lot of checks in the background to see if the object has been destroyed or not. And if you start using reference equals, then you will run into other problems, because sometimes you would expect it to be true when it's actually false. And that is, if you have an image that doesn't have any pixels to draw, it has no sprite, then you would expect that it's null, but it isn't, because it's still pointing to a non-object. If you want to go do really fast calculations, then you should go and try the burst compiler and the job system that recently came in Unity. It's a bit difficult to use it. You have to write code that has a very clear input only with primitive data, a very clear output with only primitive data, and the calculations can only access that data that you send as input. We're currently trying to add the burst compiler to our own physics engine to see if we can speed things up. And it will be interesting to see the results of that. And the job system lets you execute stuff in parallel. Mobile phones have more than one processor, and you can parallelize stuff with the job system and burst compiler and save a lot of rendering time or CPU time. Next slide is gone. Okay. Am I still with you guys?
Ja, nu kan du komma till oss.
Yeah.
Ja.
Okay. Yeah, seem to be a hiccup there. How much time do I have?
Well, how much more time do you need?
Yeah.
I think we have like 10 minutes left, but I think we want some questions in this as well.
Exactly.
So maybe 5 more minutes.
Yeah, I'll just wrap this up. There's some interesting stuff here.
Yeah.
It's some general tips for optimizing your C# code or any other programming language you're using. It's faster to use structures of arrays than arrays of structures. And what that means is that you should put the data that you want to operate on in a tight array without unused data in between. So if you look at the example on the right side here, we're having vectors with 4 elements in them. And we want to multiply the first 2 elements and then save them in the 3rd element. And then we want to divide the first 2 elements and save them in the 4th element. And we can do that in the loop at the top here. So we first do the multiplication, then the division, and we do that over and over again. It's actually faster to instead separate all the components, the 4 components of this vector, and first do all the multiplications. And we also unrolled this loop to actually do 4 multiplications at the same time in every loop step, which could take advantage of the CPU's single instruction multiple data operations. It can do 4 multiplications in one operations than doing only 1 in one operation. And after doing all the multiplications, we can do the divisions afterwards. And this requires that the arrays are divisible by 4 in this example, which if they aren't, we can just pad the arrays with zeros or something to make them divisible by 4 to avoid an if statement checking if we're at the end of the array. My screen that's not loading was my favorite, but I'll skip it. So some thoughts on angles and math. Of course, a great way to optimize is to optimize your math, simplify calculations, do analytic simplification. And for angles, you're often not interested in the actual angle, but you're interested in how the point is rotated. You want the cosine or the sine of the angle. And that is embedded in the dot product and cross product. If your vectors are unit length, then you can try to see if you can avoid angle calculations and instead use dot and cross products. And the Euler-Quaternion function that has to do with angles is slow to use. Instead, you can use the angle axis function, or you can calculate the quaternion yourself with this formula, which will be faster if you do it a lot every frame in your game. Square roots can often be avoided. Instead of you calculating the square root, can you use the square itself, for example, when comparing lengths? And you can try to avoid divisions unless you're dividing by 2. Dividing by 2 is very cheap, but dividing by other stuff it's much slower than multiplication or addition or the other operations. I just want to mention the entity component system. It's not something we're using. It's great if you have a lot of units in your game that's moving around. We don't have that in our games. We have very few game objects. But the idea here is to do a more object or move over from object-oriented design to data-oriented. So it's more like this example where you have a structure of arrays. So you have data tightly packed, and you do an operation on the data, and then you move to the next type of data. It makes it more difficult to program, but if you have an RTS game or something, it will benefit you. Maybe in future games we'll start using this. And to sum this up, an important quote by a famous computer scientist, Donald Knuth: "Premature optimization is the root of all evil. Don't optimize your game too early, because you don't know if the code you're optimizing will make it to the final game. We have thrown away so much code, so much work, and replaced it with something new. So optimize at the very last minute before you release the game." And that's the end of it. If you want this workshop, I can email it to you. Just send me a mail at peter@turborilla.com. And I also have some extra slides that I didn't go through now that we had on our internal workshop for a number of different things. And yep, that's it for me. If you have questions, please type them in the question field.
Really, really good, Peter. Thank you very much.
Thanks.
It's a lot to think about. I got to ask you, because we were talking to Zero from Unity a couple of weeks ago, and he described quite a lot what's happening in Unity, and they are doing quite a lot of how Unity functions. How do you feel with the new redone Unity?
Oh, I feel it's a step in the right direction. It's all the stuff they're making is stuff that we want, and we want to upgrade our games to use all the new features as soon as possible.
Yeah. Which version of Unity are you on?
We're on 2018, and we're switching to 2019 now.
Okay, cool.
Yep.
I also got to ask you, because you're focusing quite a lot on mobile. How old phones do you really support?
Yeah, we will for the new game we will support iPhone 6 and up, and yeah, something similar on Android. Don't remember the exact Android version we support.
How do you reason when you select how low to go?
Yeah, we try to find as much data as possible on how many users are on those phones, especially by looking at our previous games, and then also looking at how much are players spending on those versions of the game. So if we're getting like $5 a month on an iPhone 4S, then maybe it's time to drop the iPhone 4S.
Yeah. And how much does that change for you when you develop? Not to have to think about the old versions of mobiles. Does it give you a lot of more opportunities to?
Yeah, it saves time, I would say. I mean, you can always optimize for the older versions and make the game work, but it will require extra time to reduce the shader complexity and reduce texture sizes and everything. So it's basically just saving time, dropping a version.
Yeah, okay, cool. I also got one more question, and that is, you're talking quite a lot about the mobile. How's the differences when you go to PC or console? Do you have any thoughts about that? Is it the same processes, or do you think it's other optimizations you need to think about?
I think it's the same, but since we haven't worked with PC games and console games that would need any kind of optimization really, then I can't really say, but the concepts are the same.
Yeah. Okay, super.
Yeah, we also have a question from Jakob Olofsson. He asks if it's possible to download the slides used during the presentations. He thinks they seem very good, a very good summary of what's covered in the presentation.
Yeah. Thank you. And email me and I'll send them over. Yeah. Peter@turborilla.com.
Super.
And you get some bonus slides.
We will also post this on our YouTube channel and post a link in Discord as well. So for you that want to look at this again, it's going to be possible for you to do that. Hopefully we'll have that out today. So any more questions? No? I got to ask you, when we got the presentation, you said that you work quite a lot with lowering the frame rate or improving the frame rate and also saving battery. How important is it to save battery?
We get complaints all the time from players saying that we're using too much of their battery. So it's quite important. And also when the battery runs low, like if you go below 20%, then you will get a real drop in performance as well.
Okay.
The phones start to become conservative with power and the game starts lagging. So it's quite important.
Okay, good to know.
Yeah.
Super, so we have no more questions. It was a pleasure to have you. Really interesting talk, Peter.
It was fun to be here.
Yeah, I have to say also that for next week we will have Joachim Achren from, he was former Supercell employee, but is now self-employed in Elite Game Developers, and he will have a talk about fundraising for game developers. So I think that should be really interesting for all of our studios. So until then, have a good time, and I'll see you all next week. Right, thank you.